Hello, I'm Victor Raymond.
Guillermo, Alvis,
Edwin, Gutierrez, and Matthew Sosa.
And we're representing Project Third Eye Officer Safety Device. So what is Third Eye? Third Eye is a device designed to help officers with situational awareness. It's inspired by retired law enforcement personnel, and it comes in a low-tech and a high-tech variant. So why is it necessary? Officer traffic fatalities are as common as homicides in active duty members. The problem is worsening now due to distracted drivers. So the most common time that research shows for these fatalities to occur is during pullover type situations. Here we have some statistics over the past 10 years. As we can see, there was an average of about 17 officers killed per year in traffic-related fatalities. Just this year alone, and these statistics are as dated as of mid-year, so July 1st, 5 officers had already been killed by being struck outside their vehicles. So when the next report comes out at the end of the year, the number is sure to increase. So what is our problem statement? It's to design a non-obstructive device to help officers with unseen dangers. It must be cost-effective and universally applicable to all vehicles. And the device must also notify the officers of unseen dangers that are behind them in a pullover type situation. Some of the standards we used was ASME, Code of Ethics of Engineers, CFR Title 47, Part 15, and ANSI Z87.1-2015. And our global design considerations. We're going to have multi-language user manuals in the 3 most prominent languages, English, Spanish, and French. The units that will come in these manuals will also be in standard and in metric to facilitate countries that use the metric system. And again, universal vehicle applicability. That's so that international police vehicles that don't all have the same dimensions can can have this device and utilize it. And lastly, but mostly low cost. We wanted to have this device be able to be marketable to everybody. And a high cost device makes it very, very difficult for departments to afford it for their whole force. And I'll hand it over to Guillermo.
For our first objective, it was to increase the safety of law enforcement by developing a product that would help monitor their surroundings and also assist them in their primary task, which when they have a traffic stop, during a traffic stop. Another objective was to develop a design affordable for every agency in the US and across the world. And also to have a simple installation and low maintenance, so no additional costs in labor. Constraints and considerations for our low-tech options. Standard police vehicle is a little over 4.5 feet. So this had to be in our awareness for the tallness of our mirror. Also, the clearance between the roof and the light bar is a 1/2 inch. So in the down position, our mirror could not exceed that thickness to not obstruct the light bar. Considerations that we had for our low-tech options was the positioning of our mechanism, whether in front of the light bar or behind the light bar. Also the orientation, whether to open towards the vehicle or towards the light bar. This was determined by best visibility to the officer. Also, we used a curved surface for our mirror for a wider view and also to take advantage of the curvature of the roof. Protection of our mechanism needed to be considered due to the different weather conditions and also difficult situations officers can run into. Constraints and considerations for our high-tech option. The available inputs on the receivers for the vehicle since they had an existing system. Also, possible interference between their existing system and ours. For considerations on our high-tech options, since we're using smart glasses with micro lens, they had to be very durable for any situation an officer can occur. Other considerations were the physical size and weight of every component, since the officer will be carrying at all times. And due to their long shifts, power consumption for all components needed to be considered. Design alternative. We had 3 designs, 2 for our low-tech option and 1 for our high-tech. For low-tech 1, which is the option we did not pursue, was to have the mirror mounted underneath the light bar. This was not pursued due to the fact that we had to remove the light bar and also have multiple mechanisms, and that would create additional costs to materials. Low Tech 2 was the option we moved forward with, which was mounting the mirror on forward or aft of the light bar. Now for our HighTech, we only had one option, and that was officers wearing smart glasses and having a live feed from their dash cam. Now for further detail on our Low Tech and HighTech, Edwin.
So I'll be explaining the low-tech design for this, and as you can see, what we started was with the preliminary prototype that we were handed was basically a static mirror that was either to be placed on top, behind, or in front of that light bar. Needless to say, wherever it's positioned, it was going to block that light bar, and it's not very effective in terms of its usability in the field. After reviewing a few designs, it was clear that we needed to go with a mechanism that was able to retract and be deployed whenever it needed. And basically, this is what we came up with, something that can slide down and hide itself under the mirror, and basically be deployed whenever it's needed by the officer. Some of the more detailed aspects of the design included, as Guillermo mentioned, adding a curvature to the mirror. This will increase the field of view available to the officer and make him a little more aware of his surroundings. Another aspect was including Delaware bushings. These are basically self-lubricating bushings that will basically eliminate any maintenance, or at least elongate its maintenance schedule. We can also, as Guillermo mentioned, is going to be opening towards the front because of two reasons. First off, because it's closer to the officer, so he's a little more aware that it's there and it's a little more effective for him. And secondly, because we can take advantage of the curvature of the mirror and the curvature of the roof in order to have more visibility of the light bulb. The motion of the mechanism was to be controlled by an actuator, in which you can see right here. This is a preliminary design of the actuator. We will probably review this depending on the cost that we are able to source it from. Its logic, basically, is to be have two inputs, a combination of these two inputs that you see here, which is having the car in park in combination with having the light bar on. And of course, whenever either of them is not on, the mechanism is able to retract back. Some of our analysis so far has been to basically perform dynamic and static analysis. The static analysis, of course, to design each component and make sure that they hold the load and that they won't fail on the field. And the dynamic analysis simply to ensure that the mechanism doesn't lock up in certain places and have to be redesigned basically. So that picture here actually shows one of those considerations. The geometry of it was simply designed in a way that the mechanism won't ever get locked up or anything like that. Of course, failure is something that we always try to avoid, but nonetheless, we can't control some of these aspects. So in a case, let's say, where the actuator were to fail on us or lose power maybe because of the car malfunction or something like that, we would simply design a certain aspect of the mechanism to have a safe failure, in which what we mean by this is simply designing a shear, basically that joint that you see there, designing it to be the one that shears first. In other words, if the officer were to take off in a high-speed pursuit, the force of the wind would simply cause that pin to fail and retract itself back to its original position. These are illustrations of the clearances that the mechanism currently has. As you can see here, you can see the advantage that we get from the curvature and the vehicle, basically allowing us to set it lower. And this is with the mirror raised from a side view. Matthew will show you more on the HighTech solution.
So the third design alternative that we came up with was to allow the video from the cruiser's dash cam to be displayed to the officer when he's out of the vehicle. Nice thing about this is that it gives the officer a view of a potential suspect's vehicle, no matter where that officer happens to be looking at any given time. At the same time, it doesn't interfere with his field of view. One of the things that we looked into is a transparent OLED display, which is actually able to be, even with an image on it, be able to see through it. You may have seen these in hotel mirrors or similar displays to that. One of the things that we were interested in pursuing is potentially feeding video from the officer's worn glasses back to the dash cam to act as a body camera. This is in lieu of a traditional chest-worn body camera, which many departments are pursuing now because of the limitations that the chest-worn body camera presents. However, this is at the discretion of Third Eye because they're the ones controlling the project as far as the individual features that we're looking to implement in the device. Again, this is just one option. Biggest concerns with this device is that it has to be worn in order to be utilized by the officer, and that it does have a potential battery life risk or battery length aspect to it, which Edwin mentioned earlier. Guillermo mentioned earlier. The signal flow path for the HighTech device is essentially to leach the signal from the officer's dash cam through the video output of the DVR that's already mounted inside the vehicle. What this means is that there's no additional breaks in that signal path, so no potential that we're going to degrade their signal at all. That will be transmitted to a transmitter in the vehicle's trunk. From there to the officer. Will be wearing a small, essentially about the size of a deck of cards, device on his belt. I know it's already crowded, but it is one of the few places that we can put it and have it not be more obtrusive to the officer than is required. From there, the signal will go to the display in the glasses, and then if there's a camera mounted on the glasses, the signal will follow the same path back to the DVR on board the vehicle and be recorded there. So there'll be no additional recording or records retention requirements generated by that device. One of the things that we did researching this project is that we, as Victor mentioned, we found that there are a lot of officer fatalities, and I specifically wanted to include a brief remark as we go into questions. The following few slides show 5 officers that have died in Florida this year on line of duty. At this point, I'd like to open the floor to questions. Yes, sir.
So you're trying to see the front of the car?
So one of the things that our sponsors brought up was that in a traffic stop or in a roadside situation, the officer's primary duty is to deal with whatever that situation is and not necessarily to pay attention to either the road surrounding him or in the case that he's, for instance, in the cruiser writing a ticket or looking up a firearm serial number, whatever the case happens to be, he can't always keep an eye on that vehicle. There's been plenty of instances of suspects assaulting officers from their vehicle or throwing evidence out of the vehicle when they think that the officer's not paying attention. This would allow the officer to be able to see that in the case of the high-tech variant. In the case of the low-tech variant, when the officer is returning from a subject vehicle parked in front of his cruiser, he would be able to walk back and be able to maintain a visual with that suspect vehicle even though he's not looking at the vehicle.
So I have a couple of questions about the low-tech. To me, it might seem a little impractical to put a mirror right where there's also a very harsh light source where you're going to be directing your view at the point and also have an intermittent light flashing at you. That's the first thing. Second, when you're 20 feet away, a mirror that is this wide, I'm not sure how much you'll be able to see or how much detail you'll be able to see walking back from a car. If your pure intent is to see what's behind you. If your intent is to also reduce the casualties associated with people that drive past the stopped officer and potentially run him over or crash into that vehicle, your point of view is in the wrong direction. So from the low tech perspective, I don't see it as a very practical approach. For the high tech, whatever video you have an officer looking at, you will always reduce his line of sight or his view. You're going to be making the eye adjust to something near, while there's also other things happening in the further spectrum. So these are things you need to consider, because if your intent is to not limit the officer from what he's doing, whether that is looking at far away, by changing that focus, you'll always be limiting his capacity to keep his eyes on both a far and near object.
I guess in each aspect that you just mentioned, you're absolutely right. I mean, for the low tech, we saw how it's impractical. As you mentioned, the size of the mirror, the fact that we're making it convex is going to reduce the size of the image as well. So we see where it can be a little impractical. And that's why we focused a little more on the high-tech solution as a more realistic option to proceed in manufacturing. So yeah, we actually see exactly where you're coming from. As for the high-tech option, I think although it's something that, as you mentioned, it will take his focus a little bit away from what's clearly in front of him. I think adding basically an image of something that can, like he said, capture sudden movements, such as someone opening the door. Even if it's not something that can visually specifically see, like a weapon or something like that, he can get a big picture idea of maybe sudden movements or things that may be going behind him. But yeah, each aspect that you mentioned is absolutely correct. It's something that we will eventually test, depending on whether we need to increase the size of the image or maybe lower it for him to be a little more clear.
Why not work with sensors instead? Have something that is on the dash of the police officer, that once he stops, it grids whatever is in front of him, and if there's any changes to that object, then an alarm happens. They do a lot of this in security, as far as gridding using lasers, or even motion detectors. That way you're also taking away the human element, because as much gear as you could put on anyone, you're also introducing the human error into that. So by automating that response, you're taking away any sort of computation that this person has to do, or any sort of decision, and just making it a machine. You're making the machine take that consideration and analyzing it, and output something that is easy for the officer to interpret, like an alarm or a flashing light or whatever it is.
Yes, sir. I understand that, and I agree with what you're saying to an extent. Coming from military, we were always trained to rely on the Mark 1 Mod 0 eyeball because it doesn't fail. And we did originally think about using sensors, especially for the incoming vehicles, which have caused several officer deaths, struck by vehicle deaths this year alone. We did initially look at that.
If that's your focus, then you're looking in the wrong direction. All your cameras are facing forward, your mirror is facing forward, the vehicle is coming from behind you.
Yes, sir. That is one aspect of what we're looking at. In our case, we chose to move somewhat away from the, in particular, struck by vehicle deaths, in order to deal with the incidents of officers being either assaulted or killed by a suspect as they're walking away from their vehicle outside the cruiser. In part, that was a decision that we made based on the perceived level of integration of multiple laser sensors in order to perform the gridding that you're talking about. It is something that we did actually look into initially. We didn't feel with our level of knowledge and expertise that it would have been feasible for us to present a working prototype to Third Eye for their approval within the time parameters. Because at the end of the day, they're our customer, and we want to present something to them that's going to fulfill the needs that they have and be a product that they can market.
So, if you go, my suggestion, if you're gonna follow the video or this approach, I would focus more on the video than on the mirror. Second, something you need to consider is video delay. You are broadcasting a video through a wireless signal.
Yes, sir.
So, even a second delay between what the camera is seeing and what's showing in your eye, that second, the suspect gets out, that's a second that officer just lost, right?
Yes, sir.
So you need to also figure out what is the best. Is it Bluetooth? Is it wireless? Is it RF? What signal should you use to reduce that delay between what the camera is seeing and what the officer is seeing?
Yes, sir. One of the numbers that I've seen so far is about 500 millisecond display and transmission and display. So if we can get that number or under, I believe that would meet that requirement. Yes, ma'am.
So my issue with the project is that pretty much everything that you're discussing is from a lack of concept of operations. So there's a reason why, like in LA, there's 2 cops in a car at all times.
Yes, sir.
And that's so that when one of them is doing something, the other one can pay attention to what's going on around them. And to me, unless you're going to look into a system like the like heads-up display, like an Oculus Rift, or something like the heads-up display in like a luxury BMW or something like that, where it actually is designed with you looking past it in mind, I don't think that this design will actually work very well, because I think it will distract the user. It's a very, very big problem to actually solve, and it's a pretty big research field in the automotive industry and in the aerospace industry for production and whatnot. And I think that it would be a lot better to have a system of sensors that helps detect rear impact crashes for a vehicle, because that's a problem that you can solve and that you can alert the officer and have them actually have a chance to get out of the way, versus having camera that's going to obstruct his view partially, and especially when the solution is just to have another cop in the car. Like, the problem is pretty much solved when it comes to situational awareness, because like you said, you were trained to trust your eyes, right? So following that model, then you might as well have a second.
I guess to add to what both of you say, I mean, something we also looked at implementing, that I believe you started to mention, it's something like using that camera, right, to basically detect changes on that camera. So for example, like when there's a sudden movement, like I mentioned, or no door gets open, as a secondary kind of device, basically adapt a vibration sensor on the officer, that whenever a certain change happens or sudden changes happens, that immediately starts to vibrate. Exactly, something like a vehicle. This is something we were probably going to look into and kind of make them work in parallel, both the OLED display with the vibration sensor. But I guess due to multiple sources of input, we didn't want to, I guess, overcomplicate it. But yeah, I mean, if it's something that eventually on the field is going to increase his awareness, it's something that we'll definitely do that. So yeah, we'll take both of those things into consideration.
I think that you guys should look at reports of how officers work in pairs versus single officers in cars, versus like LA County, LAPD versus like Miami-Dade County. I'm sure there should be reports on that.
Yeah.
The single biggest issue with that is, and third eye would have to help me on this, I don't remember what the exact starting officer salary is, but I know that salary, no matter how much this device comes in at, would be able to purchase a department dozens of these devices against a single additional hire. And that is the single biggest thing that we're trying to do, is make it so that the potential expenditure of a single officer, a single additional officer's salary, that when you have to put, like you're saying, if there's 100 cruisers out at any one time, that's probably in the neighborhood of $4 million a year just in salaries. So for anywhere near a significant fraction of that, you'd be able to equip every single one of those cruisers with a device like this at a cost of, what do you call it, $100 and change for the...
For production of both options, we've been looking at different components and different things, and taking into consideration even the options you suggested with radar or potential image recognition. The subcomponents themselves are very cheap when they're purchased abroad, and then a prototype could be taken back to a major manufacturer and shrunken down to their actual final size. However, those prices that we've been quoted at have been around $100. So for a feasible product that can be produced at about 100 or maybe even less when you're talking bulk, because these are individual components we're still sourcing. In a bulk purchase of thousands of these units, they could probably be cut down maybe a quarter of that. They could be cut down about 25%, maybe over our price of purchasing these individual pieces. They could then proceed to sell it at, even if they sold it at double the price, you're still coming in way below the figure of officer salaries. Plus you're talking about hazard pay on top of that, depending on what they're working. And certain departments just aren't equipped to have 2 officers in a vehicle at one given time. It's a simple solution, granted, but we're trying to develop a solution for departments that don't have the funds to accommodate 2 officers per vehicle.
So, as far as testing, how are you going to validate it?
So the goal would be to, within the very early portion of next year, to get out a working prototype, which may very well not be an aesthetically pleasing final prototype, but something that you can give an officer to wear that'll still protect his eyes, still allow him to see, in the case of video classifiers, still allow him to see both the video and whatever his primary task is without being a burden on his attention, and have them tested. That would be the goal, at least as I see it. Third Eye obviously needs to weigh in on that. This is really their baby. But
that's great for like the second stage, but I don't think you would want to wear, or yourselves, would you want to test or put an officer's life in your hands testing a product that has seen no other testing?
understand.
Well,
So what I'm trying to suggest is, even before this hits the field, you should consider setting up a testing plan where you have 2 cars and you run through different scenarios that I'm sure you have data for, as far as suspects exiting the driver's seat, the passenger seat, the rear seats, through the trunk, whatever, and running and understanding if there is reaction time improvement when the equipment is being worn. Because the last thing you want to do is give an officer the product and tell him this is going to save your life, and then find out there's issues with that product.
I agree 100%.
You need to test this, and you need to develop a testing plan that you can give to the company supporting you, to run through all the different scenarios, run through the safety measures. What happens if the officer runs 20 miles, or I mean not 20 miles, for 20 minutes? Will the battery or his receiver in his belt handle that vibration, or will the camera dislodge from the glasses? You need to run through all these things to understand what is the capability of your product, and understanding if it is showing an improvement in reaction time from the officer, just not having the camera, having 2 people, or having just 1 officer with third eye.
If I could,
I need
listen, one of the constraints that we're giving the students when we first met with them, the biggest constraint was the fact that finances. Okay, we wanted to look at some of the smaller departments, especially in the state of Florida, that just can't afford to pay salary and benefits for a second officer. You're talking 3 additional officers per car now, but you're talking 3 shifts, so you're talking 3 additional officers just as a minimum. All right, and the next thing was, when you look at maximizing your ability to put more units on the road by having third eye, it's a force multiplier for us. Okay, so it would help us deal with the financial aspect of it, because now we're maximizing our potential to put more units, not 2 guys in a car, but more units on the road, plus giving them an opportunity to enhance their awareness, their situational awareness, by having this device in their units. So I think you guys have done a good job with that, because we're looking at this thing on a global market as well. Okay, there's a lot of third world countries where police officers' department may only be a 7, 8, 10-man department, and they may be patrolling hundreds and hundreds of miles of roadways within that given area. So our goal here is to improve our officers' survivability, utilizing high and low tech opportunities. We want to give that opportunity to that officer in that department. And I think this gives us the best chance of giving that officer back home at the end of this show.
Thanks, sir. Yes, sir.
I just want to redirect you one more time here.
And
I heard your comments. You're working on a capstone project. Capstone project is for its mechanical engineering degree.
Yes, sir.
Make sure that when you come back to us next semester, you've demonstrated your skills in mechanical engineering. Make sure that you've got data that shows that your years of schooling have actually produced an output that we'd be proud of from the standpoint of the classes you've taken. I want to make sure that it's not just an assembly project, that you've got some design in it, that you've got some demonstrated engineering skills.
Of course.
Because that's what we're going to be grading you on.
Yes, sir. Thank you.
And if I could finish, as far as testing of the unit, we're working hand in hand with the students to make sure that the device is going to be put through the stages of development. For instance, when we do our officer survival training and our firearms training, the goal and the plan is to have this device, once the prototype is made available, and utilized in those scenarios. So it'll go through the paces before the device is actually put on the road. We'll make sure, because we know our lives are dependent on it. So it's going to go through the phases, and we're walking hand in hand with the students doing that. They're keeping us informed about their progress. So as you saw in one of the slides, you saw a picture of one of our patrol cars. So we're working hand in hand. They're working with the training academy for the Florida Air Patrol as well. So I believe all the bases going to be covered as far as making sure this device is tested.
So I agree that that's the way that it should be done. My only issue is that not any one of those people standing up there know what situational awareness actually means, because they're all mechanical engineers and not human factors engineers. And that plays a huge role in how you define how a product is applied to the human. And I know this firsthand because one of my close friends back from where I work is designing the human interface for a spacecraft that's going to fly the next American astronauts into space. And their job is pretty much the only thing that's holding the project together, because without their expertise in how technology affects the human, nothing goes. And no one there can even define what situational awareness is.
I beg to differ, sir. I apologize. I'm 8 years military. I would not say that I can't.
From an engineering standpoint, there's a complete, I agree, the military expertise does help, but from defining requirements as to how any human can interact with it, it's a very different thing. And to me, you guys need to talk to someone who has a degree in human factors engineering, who can help you set up your test guidelines and set up your criteria, because I don't think that anyone in this room wants this to get to a point and see it fail because of lack of information or lack of like that one thing that you needed, right now.
Understand.
And so I think you guys should talk to someone. I like Embry-Riddle Aeronautical University in Daytona Beach, and see if some of their students can help out, or some of the students can give you pointers on what that actually means, because it's definitely going to make a huge difference in how you test this product and how this product actually unfolds or doesn't unfold.
Thank you.
Thank you, sir. Any other questions? Thank you all.